Here we go with the last of the center of mass lectures. So we think about the human body, and I mentioned in the previous practice problem or example problem that we were looking at this car and people, and we've got people that we're simplifying as particles, but people aren't particles. We've got really dense skulls and some brain matter, hopefully, and then we've got like our chest, which is full of heart and lungs, but the lungs are kind of sometimes full of air. And so the center of mass of a person's body isn't at the geometric center of the person, but the geometric center of the person changes based on how a person is arranging their body, right? If I stick my arms out sideways, I change the geometric arrangement of my body. Or if I am doing yoga and I perform downward facing dog, now I've made my body into sort of an L shape. So our center of mass changes based on what's in our body, but also how our bodies are arranged. So your textbook gives you center of mass of parts of typical human bodies as given as percentage of the mass of the object. Then we consider, it's not going forward. Then we consider how the center of mass of parts of your body may change based on how your body changes. So we have the knee joint as a hinge. We consider the center of mass of maybe the knee itself compared to the center of mass of the thigh, like maybe the thigh muscle or the thigh bone or both, the center of mass of the calf and the center of mass of the foot, and how the center of mass of your leg when it's stretched straight out is just above your knee, circled there in red. Instead, when you bend your knee and place your foot flat on the floor, the center of mass of your thigh is here. The center of mass of your calf is here. The center of mass of your foot is here. And now the center of mass of your whole leg falls below your knee and outside of your leg itself. So the location of the center of mass of your leg depends on the position of the leg. It's pretty interesting. Your center of mass is changing as you change the arrangement or orientation of your body. I think I just went backwards, actually. What happened here? There we go. So high jumpers have developed a technique where their center of mass actually passes under the bar as they go over it. It allows them to clear higher bars. I don't know a whole lot about high jumping. I suspect Mr. Doty could help us answer this. But I can see, at least in this position, this athlete has his feet below the bar, and a whole lot of his torso is also below the bar. And so in this position, his center of mass lays below the bar. And I'm assuming that as he sort of slithers over the jump, he is keeping that center of mass as low as he can so that he can clear a higher bar. It's an interesting application. So the total momentum of a system of particles is equal to the product of the total mass and the velocity of the center of mass. We have already calculated the momentum of a system by calculating the momentum of each particle, mass times velocity. We could now calculate the momentum. I wish I could undo that. We could now calculate the momentum of